Good morning, good afternoon. This is Mr. Payne bringing you Unit 4, Lesson 10 and 11, The Truth About Graphs and Graphs of Linear Inequalities. We're going to combine these two lessons because they go hand in hand, and we need to just pick up the pace a little bit due to the beautiful November storm. So let's start with Lesson 10, Graphing Equations and Inequalities. Any coordinate pair that makes the equation of inequality true lies on the graph. Second point, the entire graph is a collection of all x and y pairs that make the equation or inequality true. You're going to see what that means. We've already practiced what makes an equation true. Now we're going to touch upon what makes an inequality true. So let's look at exercise number 1. Consider the linear equation y equals 4x plus 2. Does the point 2, 10 lie on the graph? So let's do a quick little review and see what I mean. Don't forget that your 2 is your x and your 10 is your y. So I'm going to put in 10 equals 4 times 2 plus 2. 4 times 2 is 8 plus 2 is 10. 10 does equal 10. So therefore, 210 sits on the line y equals 4x plus 2. Let's go to exercise 1. I would like you to do exercise 1b on your own. Now I want you to find out if the point -1, 4 lies on that same equation. Go ahead and do that on your own. The answer to that 1b should be no. It does not lie on the line. Let's go to exercise 2 now. The equation y equals 2x squared minus x plus 5 describes a parabola. Does the point 320 lie on this graph? So plug in our information. 20 is my y. 2 times 3 squared minus 3 plus 5. 3 squared is 9. 9 times 2 is 18. Minus 3 plus 5. 18 minus 3 is 15, plus 5 is 20. 20 equals 20. So that point lies on that graph of a parabola. Exercise 3. Determine for each of the following inequalities whether the point given lies on its graph. So we're going to go into exercise 3 and we're going to talk about inequalities. We're going to look at A first. 4, 1. Y is greater than 2x minus 5, So 1 is greater than 2 times 4 minus 5. 2 times 4 is 8. 8 minus 5 is 3. Is 1 greater than 3? The answer to that is no. So this point would not sit in the solution for this type of inequality. B, 2, 8, 4, x plus y is less than or equal to 10. 2 plus 8 is less than or equal to 10. 10 is less than or equal to 10. This would be true. So therefore, 2, 8 would sit in as a solution for that inequality. We're going to take a brief look into next chapter, systems of equations. A system of equations is a collection of two or more equations joined by the AND truth condition. I want you to pay attention and underline the word AND here. Because the AND condition is only true when all of its components are true, the solution set of a system is the collection of all points that result in all equations or inequalities being true. Remember that with the word AND, that we have to have both of these statements have to be true in order for them to be a true statement. That is a review from what we learned about the AND statement earlier in the year. So let's look at exercise 4. Determine if 3, 1 is a solution to this system. We're going to say 1 equals 2 times 3 minus 5. 2 times 3 is 6. 6 minus 5 is 1. 1 equals 1. So that is true. We're going to now go to this side. 1 equals negative 4 times 3 plus 13. Negative 4 plus 3 is negative 12 plus 13 is 1. 1 equals 1. So that is a true statement. So the point 3, 1 sits on both of these lines, and you're going to learn next chapter. That's where these two lines intersect. Let's go to number 5. Does the point 5, 15 lie in the solution set of the systems here? So you have to do the same thing and now dealing with inequalities. 15 is greater than or equal to 4 times 5 minus 7. 4 times 5 is 20, minus 7 is 13. Is 15 greater than or equal to 13? The answer is yes, true. Let's go to the next one. 15 is less than 5 squared minus 10. 5 squared is 25, minus 10 is 15. Is 15 less than 15? I would say false. And because one of these statements is false, the whole solution is false. This point does not fall in the solution set for both of those inequalities. Exercise 6 is the point negative 2, 5, a solution to this system. So I'm going to have 5 is greater than 4 minus negative 2 divided by 2. Make sure you change that to a plus. 4 plus 2 is 6. 6 divided by 2 is 3. Is 5 greater than 3? Yes, that is true. On this side, 5 equals 3 times negative 2 plus 11. 3 times negative 2 is negative 6 plus 11 is 5. 5 equals 5. So that is true. So this statement is true because both statements are true. We're going to now go to lesson 11, graphs of linear inequalities, and let's quickly talk about my inequality rules. This is my less than symbol, knowing that, see my little L here, if you trace it. We're going to have a dotted line. We're going to shade below. My greater than symbol is dotted line. We're going to shade above. Less than or equal to is a solid line, and we're shading below. Greater than or equal to, solid line, and shading above. Copy these down at the top of lesson 11, please. I would like you to take a moment, hit pause, and I want you to see if these 3 points, A, B, and C, and 1A, if they are going to fit into the solution, y is greater than x plus 3. So go ahead and do that at this moment. Okay, you should have hit pause and you should have figured this out. I'm going to give you the answers now. A is yes, that will be in the solution. B is no, that will not be in the solution. And C is no, that will not be in the solution. So let's go ahead now and graph y is greater than x plus 3. Knowing that my M is 1 and my B is 3, and this line tells me that it's going to be dotted, and it's greater than, so it means we're going to be shading above. So let's now go ahead and graph it. I'm going to begin at 3, 1, 2, 3, put my dot in there. Now I'm going to go up 1 over 1, up 1 over 1, then I'm going to go down 1 over 1, just to make an easier line, and I'm going to graph my line. I'm going to hit undo, and I'm going to tell you why I hit undo in a second. It should be a dotted line, and with my graph, it should be a dotted line. Now I can go ahead and I put my arrows back in, and I said I'm going to be greater than. So I'm finding where my y-axis is greater than that dotted line. It's up here. So that's where I'm going to shade. I'm going to shade this entire area in. And when I shade that area in, all we have to do is draw my lines like this and shade it in. And you don't have to scribble it. The next piece that they're asking you for, I'm going to do in orange, is these points. Let's prove this. Let's go to 2, 7 and make sure that it's in the solution set. So over 2, up 7, 1, 2, 3, 4, 5, 6, 7. This is going to be point A way up here. So is that in the solution set? Yes, because that graph continues on. 0, 1. 0, 1 is right there. B. That is not a part of the solution set. Let's go to 1, 4. 1, 1, 2, 3, 4. 1, 4 is going to sit right on the dotted line. That is why it's no, because this is a dotted line, so none of these points that are included on that line are part of the solution. Now it says a fourth point in the shaded region to make sure our graph is correct. So I'm going to pick the point negative 1, 2, 3, 3. I'm going to pick this point right here. And we're going to call that point D. And I'm going to pick negative 3, 3. I'm going to try that out in my solution. So 3 is greater than negative 3 plus 3. So is 3 greater than 0? And that is true. All right, exercise number 2, 3x minus 2y is greater than or equal to 2. We have to get y by itself. So I'm going to say, all right, minus 3x on both sides. Cancels out. I'm going to have negative 2y is greater than or equal to negative 3x plus 2. I'm going to divide by negative 2. Warning bells should be going off right now because I'm dividing by a negative sign. Don't forget, when I divide by a negative, I have to flip my inequality. So I'm going to have, this is going to cancel out. Y is less than or equal to now 3 halves x, because a negative divided by a negative is a positive, minus 1. My m is going to equal 3 halves, and my b is going to equal negative 1. So now I'm going to plot my point. When I look at my inequality, I know it's going to be a solid line, and I like to write this stuff down just ahead of time so I have it all mapped out. And it's less than, so that means I'm going to be shading down. So let's go ahead and now graph that point. I'm going to begin at negative 1 on my y-intercept, and I'm going to go up 3 over 2. Up 3 over 2. And I'm going to have a solid line through my graphs. And I'm going to shade below. That's how you graph an inequality. Now D says, I want you to pick a point that's inside that solution set and prove it. So I'm going to pick 1, negative 3, or 1, negative 2 would be fine as well. So I'm going to put it back into my original problem. 3 times 1 minus 2 times negative 2 greater than or equal to 2. 3 times 1 is 3. Negative 2 times negative 2 is positive 4. It's greater than or equal to 2. 3 times 4 is 7. 7 is greater than or equal to 2. So therefore it's true. The point 1, negative 2 does lie in the solution set, and we graphed it correctly. We're going to quickly just refresh our memories on horizontal and vertical lines as inequalities. Don't forget that this symbol means that it's going to be dotted. So I'm going to put a dotted line where x is equal to 4. 1, 2, 3, 4. And now I'm going to draw my dotted line through x equals 4. I'm also going to now shade to the left because the arrow is pointing to the left, and I want to have all x values that are less than 4 shaded in, and therefore I do right there. Now I'm going to go to y is greater than or equal to negative 2. I'm going to put a dot on negative 2, and now it's a solid line because it's greater than or equal to, and I'm going to shade in all the values of my y-axes that are greater than negative 2. If you notice, all these are shaded in. Those are the easy ones that kids really do screw up, so let's pay attention to those. Don't forget, write up a WSQ, make sure your notes are all complete, and have a great Thanksgiving.